moving on to the next topic for today, which is some advancements in the RLGO solver. Um, so the FICO 2025.1 version just released a couple of weeks ago, and there have been some advancements in the RLGO solver, which we will be talking about in this session. So there have been some significant runtime reductions as well as accuracy improvements with the RLGO solver, and depending on the example, there can be several orders of magnitude uh, uh, that that is improved with the solver. So a couple of algorithmic changes were made to the ray launching geometrical optics, or RLGO, for incident plane waves. Um, the newer, I would say, version, it utilizes larger ray beams, which enables a coarser ray launching grid. And because of this, it significantly reduces the runtime, since there are a fewer rays that have to be traced and a fewer rays that have to be evaluated. And because of this, it also improves accuracy through a very enhanced ray beam integration scheme. Now, these gains are particularly useful for electrically large models where the ray count and the simulation times can become significant. So we'll look at two short examples as well, and how these new changes have accelerated the accuracy as well as the runtime. So some of the usage considerations that we'll discuss to take advantage of the solver improvements. It helps to understand the changes in ray launching behavior. So FICO now defaults to adaptive ray launching. This method determines the ray beam width based on the geometry rather than using a fixed grid that was based on wavelength. So in the previous versions, which is FICO 2025 and before, um, there was a fixed grid that was used, and which was completely based up on the wavelength. But with the new version, it is now based on the geometry. Um, so no user changes are required to enable the adaptive mode. Existing models will benefit automatically, so without making any changes. However, for those using fixed increment mode, we recommend that the increment be chosen relative to the geometric scale of the model rather than the wavelength. Because smaller increments may unnecessarily increase the runtime without any corresponding, I would say, accuracy gains. Now, when it comes to RLGO, the mesh size directly affects the RLGO performance. In adaptive mode, the mesh size influences how the rays are launched and where the refinement is applied. So we recommend using the coarsest mesh that still accurately represents the geometry. If you use overly fine meshes, especially those that are created for other solvers like MLFMM, that can significantly increase the ray count and it can degrade the solver efficiency in RLGO. So in the illustration shown, we can see that a simpler mesh would lead to a shorter simulation time without sacrificing the result quality. And this approach, it aligns well with, I would say, the updated beam handling in the 2025.1 release. So here is an example of a dihedral PEC reflector that is simulated at 100 gigahertz. So the physical size of the model, it spans over 300 wavelengths. Now, using a simplified mesh with only 23 triangles, we simulated both the near field and the far field results. And this scenario is useful for validating how RLGO performs with high frequency models that benefit from reduced, I would say, reduced ray complexity. So here for the same dihedral reflector at 100 megahertz, we have a plot that shows the electric near field magnitude along a line that is parallel to the surface of the reflector. So in FICO 2025.1, the results are consistent across all the accuracy settings. So low, normal, and high. Um, and this consistency suggests that even at the default or even at the low settings, one can get usable results in many cases. And by contrast, we can see that the previous version shows some variations at lower accuracy, particularly, I would say, near the transition regions. And here we compare the bistatic RCS results over an angular sweep. So the curves from the FICO 2025.1 version, they show good agreement across all accuracy levels, including the low accuracy level as well. In the earlier version, the low accuracy result, it differs more noticeably in terms of peak placements, I would say. Even in some places, the curve smoothness as well. And on the right, you can see that the inset, it provides a closer look at all of those angular resolutions, showing the field behavior and the interference patterns. So we can see that all of it is preserved with fewer rays in the updated solver as compared to the previous versions. And this slide, it summarizes the change in the ray count and the total runtime for the dihedral reflector simulation. For FICO 2025 at high accuracy, it launched over 140 million rays and required more than 5 hours to complete the run. With the newer and updated version, the same simulation required only 123,000 rays and completed in under 20 seconds. So that is quite a difference in terms of runtime. Um, if we look at the normal accuracy setting, it's about 202 times faster. And if we look at the high accuracy setting between the two, it's about 1029 times faster. So a huge difference, especially for those models that are very big in terms of its electrical size. And we have another example here. So this example is of a monostatic RCS of a wind turbine at 500 megahertz. Here the goal was to compare the RLGO results with an MLFMM reference. So if we were to run this model with the MLFMM solver, it would have taken a long time. I would say up to several days, and that too with poor convergence. While with the RLGO solver, this could be solved in a few seconds or minutes. So in FICO 2025, the normal accuracy setting was needed for a close match, which would result in a runtime of about 321 seconds. The low setting produced a visibly different curve as we can see in the graph where it says incorrect result. So you could still run this with a low accuracy setting, but it did result in some inaccuracies. In contrast with FICO 2025.1, we've achieved a similar accuracy using the low setting with a runtime of just about 41 seconds. So this shows that even the lower accuracy levels in the new RLGO solver can now be used more confidently in certain scenarios. And here we have a summary slide of the performance metrics for the wind turbine model. So MLFMM required about 150 hours of compute time and more than 90 gigabytes of memory. Whereas if we look at RLGO in 2025.1, it provided comparable results in under 1 minute and with less than 40 megabytes of memory. So for electrically large or repetitive simulations, the updated RLGO method offers a practical alternative, I would say. Um, and with much lower hardware requirements as well as turnaround times. So I have one more example to share about RadHaz analysis for a naval vessel at 10 gigahertz. So this is also a complex case with about 5,600 mesh triangles, and we've looked at the far field request with RCS analysis and the near field request for RadHaz analysis. And done a little comparison of the two versions. So with the previous version, which was FICO 2025, um, with the low accuracy setting, it was resulting in some inaccuracies and incorrect results. And with the high accuracy, um, it was taking a very long time to compute the results due to the number of rays that were considered. But with the newer FICO 2025.1 version, we can see that, or we can just observe that all of the three accuracy settings can give us similar results. So we also have a little comparison of the electric field um, along the line of the naval vessel. And if we look at the traces or the graph, we can see or observe that FICO 2025.1 gives out a more stable result even with the low accuracy setting, and it's very similar to the high accuracy results. So there is not much of a difference when it comes to low accuracy versus high accuracy, and the results are still stable and trustworthy. And we've done a similar comparison for the bistatic far field RCS as well. And we can observe the same, that the low accuracy setting gives very similar results to the high accuracy setting, and kind of gives us the confidence in the solver itself. So just to conclude, a little summary of the RadHaz analysis of the naval vessel. Compared to the previous FICO 2025 and previous versions, we can see that the 2025.1 gives more accurate as well as faster results. It's up to 230 times more faster, I would say, in this particular case with the normal accuracy. Um, and if we look at the high accuracy setting, with 2025, it was not able to compute itself due to excessive runtime. But with the newer and updated version, we can see that it converges or gives us a stable output within 7.67 hours itself. So I hope that gave you a little insight about the new and improved RLGO solver.